Millennium to power millennium. Good morning, everybody. Namaskar, million to power million. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on today, March 29, 2022, Tuesday, 3:34 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ आज दिनांक 29 मार्च 2022 मंगलवार 3:34 and present to you continuation of this talk. Title being Real Quality, Coordination Engineering, Projects Works, Reliable Engineers, Power of Communication, Concrete Specs and Civil Engineering Contracts, Designs, etc. etc. As usual, as every day we talk of, and you can see my email ID which is here for you to see. This email ID is Suraj underscore engineer. Suraj, you can see that email ID Suraj underscore engineer at yahoo.co.uk, and this is my telephone number and address, but please don't call me. If you want to raise questions, send mail. Again I say Suraj underscore engineer at yahoo.co.uk. I am Chartered Engineer India based on my FI registration, FI membership, and also I have qualified International Professional Engineer title. It's third time I qualified. I have been professional engineer for long and chartered engineer since 1981. And here is another certification. That's professional engineer certification. You can see International Professional Engineer India. It's a certificate, it's not an award, it's based on competence. And then there is another certification, it's Chartered Engineer India. Chartered Engineer India, and that says this is based on fellow membership. It's also based on membership as well. It's also based on associate membership of Institution of Engineers India. And here is our quality related file, as well as you can say coordination files, and also we have many more files that are not opened yet, and these shall be open. And concrete open access, concrete JC, this is a file. Melamine, I think we are done. Naphthalene, let us see how much naphthalene was left last time. I discussed melamine, then it was naphthalene. I think we had discussed about naphthalene totally. What was there left? Let me see. Health effects regulations, and there was a file. Let me see which file is still pending to be discussed. Well, I think it may be melamine. Let me see. What about melamine file? Melamine file. Let me see. Just a minute, please. Because I left yesterday some discussion on this. Etymology melamine, we discussed like that. Current preparation food. Okay, this is that one. Melamine poisoning and treated food. We'll go to this one also. So these two files are open now for discussion. This file, I better close this file, which we'll see later on. And also I open Japan specifications file. Japan specifications file, that's for concrete, and that's here. Japan specific files. I closed down Chartered Engineer file, I closed down fellow file. So my dear friends, I'm going to talk about issue of quality, Gunavatta in Hindi, and I don't know what's in Arabic, but generally we call it good work or strong work, majboot work. Quality is part of that. Quality everywhere is required, we know that, and we cannot go without quality. If you go without quality, means we go nowhere. Quality is quality. You accept or don't accept, word accepts or doesn't accept. We cannot escape, we cannot get rid of that. Even if we are careless, means if will speak, I am not available. If you don't do quality work, or work shall speak, I am not available. To that mark, that standard. So quality is hallmark of your life, quality is hallmark of your thinking, quality is hallmark of your work, it's hallmark of your life being, your health, your mind. We say this person has sound mind. Why do we say that? We never say this person has sound health, we always say this person has good health. And we say this person has sound mind. A person should be of sound mind. What does it mean? This means person should have acceptable quality criteria that's required for mind. That's why I say mind is very important. If mind is quality one, and we use mind, those people who don't work using mind, who don't work using mind, those people can't be called quality people. And quality is up to you, means it's in your hands, it's not in the hands of others. You cannot blame someone else if you don't get quality. You cannot say I didn't get quality because this person didn't help me or didn't work. That is just an excuse, and this cannot be accepted. Quality means you are working, you have to work qualitatively. If you do not work qualitatively, this means quantitatively also you have not worked. Even though you have worked, but that does not measure to quality, that does not qualify to quality standards. And that's why it's a very serious issue. It's serious for everybody, but if, particularly for engineering world, for engineering professionals, for engineers, for workers, for those who come in between workers and engineers, and of course industrialists and manufacturers, and you can say constructors. Quality should be in their hearts and in their minds. And if we do not do that, we just claim that this has this much level of quality. That claim got no meaning if your quality does not work. That's why title starts from real quality and goes to what we are. It is quality only that indicates what we are. It's quality only that indicates how far can we go, what potential we have if we know how far we can go. This means we have certain potential to move, and that potential comes from quality. It's that way you can say some person is in one student, young students say, I study. There are two ways to study. One is to just study that one. That's enough for passing examination. And we say, okay, I study this select question based on past records. And my objective is to pass or get through examination. That's one part of education or criteria you fix for yourself, because your own aim is, your objective is just to pass as an examination. That's one part of quality. Other part is, no, I have to study this subject thoroughly. I should know what this subject is. I should understand each and every aspect of this subject. I don't want just move on subject, but I want to eat this subject. I want to grasp this subject from each and every aspect, so that I know what is this. For example, subject of mathematics, which you cannot do by cramming. You cannot do I did that and I repeat that. That's not done, because mathematics is calculation based, it is mind based, it is logic based. Same way physics and chemistry. You cannot cram. You have to solve numericals. You have to solve chemical equations. Likewise, there are subjects where you must have clear concept. If you don't earn, if you don't enjoy, if you don't study properly, no way that you can have clear concept. And that clear concept measures your quality. What level of concept you have about this subject or about this study, that is important. An engineering world, cramming is not required. If you cram, you cannot pass anything. Engineering is based on clear theories, clear practicals, clear formulas, first principle, second principle. Engineering is full of that. And if you don't understand that, you cannot do engineering. That's why I often claim that engineering means what? Engineering means facts. Without facts, engineering cannot be done. And facts means reality of life. Though sometimes we imagine, sometimes we assume, just for purpose of formula calculation, but at end we apply real value and get answer. It happens. Means a format is required. Say we do work on worksheet. There are so many cells in worksheet. We have to fix some formula. Then we just assume some values for that formula and work out that formula on worksheet. But when real value we feed in those editable cell values, we can edit and we can get results. So for purpose of formatting, purpose of formulating, we say we need certain imaginary values. But real life would give you real values. That's what I say. Engineering is based on facts. If somebody falsifies this means that person does not understand what is engineering. Everywhere in engineering designs, engineering theories, engineering applications, we use factual information. Without that, engineering has no value, engineering has no meaning. When we calculate, when we work on designs, people do not understand in general that design is based on facts. It's not based on assumptions. We have, for example, we calculate weight of buildings. How do we reach that? People may not understand how can you weigh building. A person who does not understand this would only say, oh, your building is so many thousands or hundreds ton. How did you weigh it? That can be a question. If I say, okay, this building I'm going to design or this building I'm going to work on, this may weigh 1000 ton. You may say that. When people will say, how do you measure 1000 ton? That's what I say. It's based on statistics, it's based on data, it's based on codes. We have certain information for weight of concrete, for weight of steel, where weight of people. When you use this, weight means weight, how, what pressure wind shall transfer to this, how shall it happen during seismic action or during earthquake. Likewise, we work out quantities of area, we work out quantities of cubic meters of concrete and tonnage of steels. Likewise, we work out other items, and then we, okay, this building has so many cubic meter or so many tons of this item or that item, so many likewise. And we sum up each and every item of that and say, okay, this is the total weight of this building and this is total force on this building that's expected due to wind or due to horizontal shear or due to whatever. And we work out. People may be surprised, how can you do that? It's done. It's done very, very ordinary, but these facts are based on system. Just like we say concrete weighs 2400 or 500 kilogram per cubic meter. Nobody weighed this. We weighed only small samples. For example, we take concrete samples and weigh them. During testing, we weigh what's weight of this, what's dimension of this, what's density of this, what's force on this that can break it. That's what it's done. So it's fact. It's not my might or my arbitrary answer. No, you have to take up. That's not way. That's why I say when you talk of real quality and real coordination, it is in fact real. Real building, real force and real resistance. Which resistance? Every member of a building. Say this is foundation, this is ground beam, this is beams, or these are vertical columns, these are beams, and this is slab. People know that much, and it's a fact also. These members, beams, columns, slabs, all that, these have certain weights, and all weights are calculated, all members' weights are calculated, forces on them are calculated. If this is a slab area, what shall we force on that? And that force shall transfer onto beams, and beams shall transfer to columns. And this is not only weight, but also bending effects, imaginary bending effects. We know it's not seen, we cannot see that building is overturning. Means it's just a situation, it's just a case study. We can say in case this happens, this tries to collapse. How shall we control? And this is way of controlling, and that's called providing resistance. Resistance to bending, and resistance to direct load, and resistance to earthquake force, and resistance to wind. This is what we do, and that's what I say. It's based on factual data, factual calculations, And of course, there are certain factor of safety use that is in whole world, that's used everywhere in the world. Engineering is not different from, it's not different one country one and other one to other. There's no such, yes, there are codes, local conditions. Due to local variations, something may differ, but principle is same, and therefore you can say it's international work, it's factual work, it's work that cannot be changed. So when we say all these cannot be changed, then certainly we have to produce those, and production of those requirements according to mandate of engineering is called quality. We have to produce quality, not only work on site, but we have to do quality designs, we have to do quality organization, we have to do quality work. Everywhere quality remains in demand. That point is very important, and that's why I say real quality and real coordination are very significant, without which we cannot do anything. And I find these missings actually. I find these missings. I try to get information on coordination, communication, etc., etc., but we could not find that. And that's the point I stress for, I struggle for. And in fact, that was not the fun. We could not find that. And as I say, on this file, for example, concrete melamine, we have discussed this melamine long. We have discussed this detection of biological metal surfaces. I'm just trying to get information from here and there, for this, for that. Chinese outbreaks is not concerned here. I think melamine poisoning by tainted food and drugs derivatives. What was that point I was trying yesterday to talk about coordination? Likewise, that's a very important point. Coordination. So this is a response to no maybe concrete naphthalene melamine. Okay, just let me go to now we do this here. That is concrete specifics. For example, let me take page something like 105 and go the year in which you're saying that what we're doing. It's concrete. Then reinforcing steel, reinforcing steel, structural steel. We'll start here. So you can say, yeah, we'll go fast on that. Pre-stainless steel. Okay, we discussed pre-stainless steel. Now we're going there. Let's say coordination, reliable coordination. We call it reliable because we have to use it. We have to depend on it. Coordination and communication. These are very important part in our engineering world. And if we are not able to coordinate and communicate properly, there is no way that we can do right work. Means we have to move on coordination for purpose of doing right job, because coordination is a process where information is gathered together. Information may be available at one point, it may be available at many points or many documents. That information, whatever it is for purpose of working, should be given to those who work on our project sites. If we do not provide that information, then how can they work? You have to think yourself. How can these people work without having good information, right information? These people cannot work, and we cannot say that it is successful in that case. Of course, work would be done practically, physically, but it won't have quality input in that. And that's what we can say. We are not engineers in that case. We can't call it an engineering job. And reliable coordination is very important for purpose of that. And if we can't coordinate, we cannot provide information at one point. If we can't provide information on one point, work cannot be done. It's like that one mason works, one carpenter works without having any documents, without having a record based on experience. They will repeat same work. That's not engineering, because you do not know facts. Means just you do what you did in past. If you made mistakes in past, you make mistake now. That's not engineering. That is just just to do without knowing anything. I don't say they do not work, but they should know. They should be given information. From where shall the information? Design information, detailed information. Engineering is so vast, and particularly civil engineering is so vast, vast in the sense that manufacture items very little. In construction engineering, you can say we don't get manufactured concrete. It's very rare cases that precast members are used. Pre-stress is very rare, but generally, even if pre-stressing is used on sites, then we have to do concrete basis for that, and concrete is provided. There is no major item. There is no major item in construction engineering that we can do. Okay, we get it ready-made, but in mechanical engineering, in electrical engineering, in all other engineering, even for major plants, vessels are available. These are purchased, equipment are purchased, machines are purchased. What is done on site? Just erection of them, and on foundations which you provide on site is a part of civil works. On site we do excavation work, we do foundations work, we do backfill work, and then we prepare everything for installation, erection. Of course, we use structural steel there, which is of course manufactured in workshops or in factories and brought to site, but no such applies to construction of concrete and other items. So we can say element of working on site is higher if you compare it to in mechanical world, HVAC world, electrical world. So when everything is done on site, you can say concrete is done site, and concrete is you can say top material which is used all over world. Of course, there may be classifications, there may be different types of concrete, but essence is concrete. That's why concrete is also given name for solid status, for reliable status. This person is concrete parameter. This person can be measured. You can say, oh, his work is concrete. He has solid opinion. His concrete opinion. Yes, your opinion is concrete. We respect this. So we have to really think a lot as far as this is concerned. And there is always saying, if you miss coordination, if you cannot understand coordination, you cannot do good engineering. And coordination does not mean you should deal sitting in concentration. No, you have to provide information, and that information has to be located, and that location you should know. You have to go through all documents. It may be work documents, you may call them, or contract documents, you may call them. Every item has locations at different points, and even your experience, you should know from which documents you can get this information, and then you find that information and you can work on that. And that's what engineering is all about. Civil engineering, collection of reliable information, collection of applicable information. That's a really wonderful and very important point that we take into consideration of engineering world. And generally, when we say engineering world, of course, it's not civil engineering alone. It means inclusion of all branches of engineering. But civil engineering is lead here, because every project starts with civil construction. And that's the important point. To start with, we have to start. You can say it's kind of starters. Civil engineering is a starter, and civil engineering is an accelerator. Before that, it's clutch. And in automation, it is just we have to set it on drive mode, and we have to start at parking mode, and we have to move on to drive mode. So engineering is that drive mode. And once this mode drives and we do it, then we have to park that project after completion, and that's called park. We parked it, we are not driving. This means your construction is over. Missing real coordination means missing good engineering, and good engineering missing means missing development, missing yourself. We cannot say if we don't have coordination. We can say if we do not coordinate, we cannot do clean engineering. If we do not communicate properly, then we cannot do coordination. And when we cannot do coordination, means we cannot do we cannot move further. And that's why there are many points are which I always discuss. And coordination engineer must, that's a question, is it must, is coordination engineer must on every project? Of course, answer should be yes. It's not only coordination, it's super coordination should be there. And it's better if engineers coordinate, if design engineers coordinate, if planning engineers coordinate, if quality engineers understand about coordination. I'm not saying that quality should coordinate, but they should understand inputs requirement. The project means performance activities. All performance activities involved from pre-designs to final completion of complete construction. Many times I define for people to remember all this. Date of start and date of completion, that's important, and that's called project. It can be design project, it can be construction project, it can be whatever else. And if you combine all this can become master projects, master plan of that work. You can say there are certain questions to be answered about quality and coordination, about respective involvement in the entirety, how to ignore, what to ignore, can we ignore, that's a point, and what engineers think over such issues. And of course, how many of ourselves conduct works for quality and coordination engineering, that we have to see. Are we expert or not? I'm sure we call ourselves experts, we call ourselves experienced, but we have to raise question to ourselves. One has to raise question to self. What quality level I have used, what coordination I have done. Did I get complete information? I did not get information. If I could not get complete information, where did I miss? Why did I miss? Why could not understand that? And that's point. And particularly those who are experienced, pragmatic, they must have all these awareness. They must have done this. They cannot say nobody told me, because there's no one to tell you. Quality, of course, quality has some standards, but as far as coordination is concerned, it's a flying profession, a flying work which cannot be named. Coordination is such a work which has many wings, not defined wings, automatically understandable wings, depending on requirements. Coordination means everything required for that work must be available in clear cut, very available explicitly. Let's say it should be available everywhere, all times, and when I use this, it should be used. There could be modification on available information, and that should also be communicated in time, so that if it's modified, one work has to be done accordingly. And that's why you say we have no right to ignore, we can't ignore, and we can't play with engineering, we can't play with information. And these issues are very important, and we have to take care of that. And if we don't take care of that, we don't take care of ourselves. And of course, we have to contemplate. Every time is right time. We have to contemplate and deliberate, because contemplation and deliberation and thinking of ways to go further, avoiding all errors, human errors, work errors. And this is what we say, good industrial practice. Can we achieve it? It's a practice to do the right job, to do quality job, to improve, to further, to think, to depend on research. And if you don't do that without moving through quality and coordination domains, then we are a failure, we can say. And what we saw about designs. Can engineering designs be reliably carried out without involving quality and coordination? How can you say that? It can't be, never be. And particularly I said the designer must understand this. I'm not saying the designer has no duty. Designers have every duty keeping in mind about quality and coordination, because during design stages also coordination is required, very, very much required. And you cannot say there's a software which can help. No, I don't rely on softwares, because mind is best software. You have to anticipate problems during construction. We have to anticipate problems during ongoing project. And we keep them. Every project has different kinds of problems. There is no set formula. There is no set book which is required in coordination. You might not have coordination engineering books very often, but this subject is very big, very vast, that we have to understand our coordination, not only in engineering, it's everywhere. It's everywhere. It's very fast, very can say burning type. We can't skip that, and we can skip, we skip ourselves. And that's reason I always press on this, I always stress on that. I used to say in writing here, no, just informative, it's not, it's not exactly what we should do or should not do. Every case is different. Every case is different. I start always like this. I say, coordination engineering is a must on every project. No one can deny this fact. And why should we deny this fact? Coordination is coordination. It should be respected. And that's where I say it's an important point. We should not play with anything. We should not play with this. That's why I say civil engineering is a must on every project. And coordination engineering must. Coordination engineering means relation engineering, we call it. It has certain relations, item to item relation, discipline to discipline relation, person to person relation, work to work relation, and combination, everything. That's what coordination engineering must in every project. And we call coordination engineering doesn't mean discipline engineering, doesn't mean branch of engineering, but it means it's a relation engineering, or you can say link engineering, or you can say overlapping engineering, or you can say it's like, you have to move on a track. There may be two tracks, you have to move together. There may be parallel track or there may be sequence track. It depends upon how to say that. Just like this is called an electrical engineering is parallel circuit. This is in parallel, or this in sequence, or this in serial, you can say. Same here, it is series or it's parallel. If it's series, you have to do it one way. If it's in parallel, you can other way, because in parallel you can move it simultaneously. But when it's a sequence, you can't do like that in series. You have to do first point first, second point second. Likewise, of course, that's what we know. Your own branch engineering coordination, other branches of engineering coordination, and complexity of project decides that what you have to do. That's the important one. So designs, construction, and controls are very absolutely interrelated, requires actions for achieving from successful part to completion of a project, which all must be applicable throughout project stages, with all works be smoothly affected. These sections or stages are initial conceptual designs. These are initial conceptual designs, these sections or stages, and that's why I state conceptual designs. The real designs to be done later, but conceptually clear. Designing for works execution purposes, and that's main. You have to design it for works execution purposes and not for sake of examination. It's not that you have to write some thesis or some paper for your reference to your guide while doing research work. These sections stages are initial conceptual designs, designing for works execution purposes, procedures, implementations about how to chart out construction of design projects works. That's what I say, how to chart out design project works, project construction work. Currency decision means when your project is under construction, during that currency, what's going to happen, and works carrying out. When you carry out what happens, that you have to keep in mind all time while designing. At designing time, of course, I know designers are involved. They are highly skilled and qualified people. Maybe they are not experienced on construction, but preferably I should, as an engineer, I would say it's also important to have worked on site first. Even if you are a doctor, you should know practical problems. Without going to site, without watching or experiencing those, you cannot consider that problem into design. And that must be considered, that's better. This means they should be aware of how works would be done, if not in details, at least superficially they should know. And they should also know means what is planning of this work, what's quality of this work that is practically capable, that's practically workable. I'm not saying imagination is always, ideals won't work in engineering. We have to be little practical as well. And so you cannot say we can be a bacteria, on these terms. We have to keep in mind that work is done by people and they cannot be perfect all the time. We have to keep that point in mind and have some safety factor as well. That's what I'm saying, that Project works, construction works, works carrying out, testing, completion and pre-commissioning and launching, use of project. When project title terminates, becomes occupation or becomes a operational unit. Designs may be considered over safe, optimum. We can have safety factor. We can know this optimum doesn't matter. It's not going to harm anybody. But real construction works, real construction involves actual expenses. We should not forget. Money is spent on works, materials, and everywhere. And if it's not done rightly, money cannot come back. There is a money question, money criteria. There is a contract time criteria. There is financial liabilities criteria. And there's an issue of reputation of contractor or reputation of promoter or reputation of owner or reputation of engineer, means likewise, which all must be cared for, and with sincerity by both stakeholders. When that time stakeholders are owner or promoter and designer, those are stakeholders at that time, because nobody knows who would be contractor, who will be vendors, like that. It should be, it should be a certain motto, it should be a certain fixed objective of an organization to apply good controls on project so as to keep in line on schedule. Planning being an actual part of controls, and control includes progress, cost escalation, time, budget, quality requirement, assurance, or both coordination, engineering as well as total engineering, and safety risks covering and delay recoveries. Here we talk of controls. What controls you mean? Means control. You have to get hold of that. Whatever work, material or otherwise. Control means hold on that. Don't allow to escape it. Don't allow escape. Hold it perfectly with mind and with hands, and which include progress. You have to produce a line of progress theoretically as well as on site. You cannot deviate from it every day. You have to keep within limits, certain time, certain safety factors. We have to understand that cost is involved, and I have no right to waste material, I have no right to waste time, and I have no right to abuse quality. I have no right to abuse safety, health and environment, and we have to maintain budget allotted to that. And of course, we have to keep in mind requirement of quality, what quality we have to produce in this. It may be called quality requirement. Generally people used to call it, still today I see people call it quality assurance, which is not acceptable practically, because assurance is assurance. It should be rather quality requirement, and I write requirement because requirement is a mandate. It's not your option, it's requirement, and you have to be pushed for that. Everything cannot be called option or assessment. No, it has to be done this way. You have to fix all procedures. You have to fix means what is required. As I said in triangle, time, cost and claims. Time, cost and what all this is there. We can say cost wise, time wise, quality wise. Quality is also a part here. When quality is linked to time and time is linked to cost and cost is linked to quality, then there is no way we can call it quality awareness, because it's quality requirement. You may accept, may not accept, and even if you are aware and you are not defining as if, even then you have quality. You have to show, you have to prove quality has done. And you can say in that case it can be called total engineering, rather than saying design engineering or planning engineering or contract engineering or execution of work on site or quality. You can call it, just like we say total quality management, we can also say total engineering, which includes safety, planning, scheduling, risk coverings and many more, whatever applies to one project. These are all integrated divisions from decisions from various disciplines, sub-disciplines. We should move in unison. There should no, this is one point, this is moving in this direction and that moving in another direction. That does not work. It cannot work. These are all integrated divisions which should move in unison to achieve project delivery targets. A well-designed project, we say it's a well-designed project. A well-designed project could be jeopardized. Meaning of jeopardize, which is a kind of emergency, a kind of requirement. A well-designed project could be jeopardized during construction phase. From budgetary viewpoint, should it not be given due required controls, application properly, without organizing with full intensities, keeping eagle eyes on project. We have to understand this by using eagle eyes, without organizing with full intensities, keeping eagle eyes on project work and construction controls. No project can be delivered in time and fixed budget. That's an important point. And here eagle eye is something very different. Eagle eye means full concentration. Eagle eye doesn't mean eagle eye. I say we have to see also different meanings of this somewhere, and that's what someone can say. Plus, let me because I'm using this word, so it's my responsibility to make it clear what I'm talking of. This eagle eye, Eagle Eye is American action thriller film. Well, I'm not talking of film here. I'm talking of something else. Eagle Eye is not. Watch Eagle Eye. Eagle Eye. It's not film. I'm talking of meaning of Eagle Eye. Meaning is important. Meaning, Eagle Eye meaning and meaning say different. Definition says careful or close watch. You can say a careful or close watch. It is eagle eye definition is ability to see or observe keenly. Means you have to ability to see keenly. One that sees or observe keenly, you have to eagle eye definition. If you talk about a person's eagle eye, you mean that they are watching someone or something carefully or very good at noticing things. And that's what it says. Sometimes we have to research these terms also from different viewpoints. I'm trying to find Wikipedia. Where start dictionary.com. Dictionary.com won't help me. Sometimes we get information, sometimes we don't get information rightly. There it is. This is Cliff Koch and dictionary Cambridge, not issue here. I'm not successful in that. I'll leave it, no problem. It means you have to concentrate on watching. So what I said was this, that we have to be careful in watching, we have to keep an eye on that, and that's what it is. And it's called, as I said, we should have legal eye on that. Without organizing with full intensities, keep eagle eyes on project and construction controls, no project can be delivered in time and fixed budget. First act of project leader, therefore, must be to get into allotted budget and then to move project within its defined ambit. So this point is very important. Leader means manager, or what you will call it. We generally call it leader or responsible functionaries, or you can say who has to respond, who has to be accountable. First act of project leader, therefore, must be to get into allotted budget and then to move project within its defined ambit. One should remember that once money is lost, there is no possibility. There exists no possibility. There exists no possibility to retrieve that lost money. That's an important point, and we should know this not only for engineering works. This also applies to whole world. Now, though it's not engineering subject, but we have to think of country, in which country we are members of. We have to, in whatever capacity we are, we may be engineering leaders or other professional leaders, we may be industrialists, we may be government people. Money lost does not come back. That is first point. And money is not currency alone. Money does not mean currency in papers or in digital form. Money means wealth. Money means asset. Money means our natural force, that is resource, or we call source. Loss of one unit, though we can say, oh, it's small loss, it's no problem, 0.1%, 0.2%, 5%. Easy to say in percentages, easy to in coefficients, but accumulation of that is enormous. At that point, we have to consider very seriously that this is a loss. Loss is loss. I also was not very serious sometimes. Being a civil engineer, could not understand everything. And of course, every profession has limitations. But when you consider that your efforts have gone waste, when I say loss of money, it's loss of work, it's loss of time, it's loss of everything. Loss means gone out of your control. You cannot bring it back. It's equal to impossible. So that's the important point we have to consider, that whatever budget we have, whatever we do, we have to do within that. We have to keep a control on that. Otherwise, that is a random work. There is no dates, and you can say even maintenance has some dates. Date of start of this maintenance contract, date of end of this contract, and we are responsible for this duration. If you want more, you have to do more. And that's what I say. Once money is lost, there exists no possibility that it has to come back. We can bring it back. Loss of money is loss of your own property. Again I say, it's not currency units. It's your efforts, it's your wealth, it's your asset of a nation that we have to think about. Just like what's happening around the world. Everybody has its own interests, and people have become more corrupt. And that's why I say corruption, survival, at cost of what? At cost of quality. Quality of life, quality of dealing, quality of commerce, quality of business, quality in every affair of life. I'm not involved in politics, but politics has a spoiled economy. Politics has spoiled everything, everywhere, all over the world. And that's why quality question comes into picture. When you don't think of money, you don't think of your nation, how can you get quality issue? That's what I'm saying. Quality is not separate. It's a part of life. It's part of work. Every individual has certain quality. It doesn't mean we have to resemble it to work, because capacity of working of an individual depends on general capacity. And if you lose your character, you lose your conduct, how can you get that? That point is very important. One should remember, again I say, no possibility to bring back lost money. Analysis tool can be required to operate with complete dedication to carry out or conduct controls. And that's what I say, analysis. It's a language of engineers, it's a process of engineers. Analysis is that life which nobody can change you, nobody can, you can say, nobody can hamper you. You have to, and you have to. And that's why I say analysis tool Analysis is, you can say, management, or it's kind of working organization. Whatever work we do, analysis is important, though either formally or informally, or it's done in mind, but it is to be done. Analysis tool can't be required to operate with complete dedication. You can say it is required. It has to be required. I thought I used not, that's why mistake. Analysis tool can be, or analytical tool you can say, can be required to operate with complete dedication to carry out conduct work. And that's very important point. We have to understand analysis is part of very much engineering, because engineering starts with analysis of whatever it is. No work can be done if no analysis is done. And that's very important point. When we do work, we have to analyze that. In engineering, analysis is leader. Engineering leader is analysis. Try to understand. I have so many people, they call themselves analyst. I am news analyst. I am this analyst and I am that analyst. But engineer is born analyst. If you take civil engineering, it's full of analysis. There is no subject in civil engineering which does not have any relation to analysis. Everywhere it is. Otherwise, there is no meaning of thinking. Analysis forces us to think. Our job is thinking. First job, starting job is thinking. And further branches go on to doing. Analysis is kind of research on works done. It's the kind of imaginary research on thinking. We call risk control, risk studies. We call this. You know what risks these? Yes, you can know. You can know using some information or lessons learned in the past. And then we can say, okay, we know this risk. And if this risk arrives us, how shall we manage that? And that plan, that management statement must be understood. And we have to work accordingly. That's why I say analysis tool can be required to operate with complete dedication to carry out or conduct controls. All required sections related activities impose total dedication for quality input within such disciplines in actions as well as in works. Whereas all such acts certainly demand involvement of engineering coordination activities at each and every ongoing detailing review ensures constructability, buildability, very important terminologies. Constructionability. We have to construct. We have to do it. Are we able to that? Or if I am there, I am available, I am able, can I do that? My ability is one part, but can I do that on works? Can I implement that? That is very important point, that constructability, can it be constructed? Whatever information we have, whatever designs we have, whatever methods we have, or we have to link these three and say, is it going to be constructible, or it is going to be only small percentage constructible, or we can construct it directly without having any problems. That's to say constructability. It means our design is constructible easily, it's comfortable, it won't cause any problem. And if we expect that this causes a problem, then what is the problem behind that cause? How can we solve that one? And that's important point here. I can say constructability almost is very important issue. We should not run away from that. Constructability is that. It can be plainly said that engineering coordination is an only formula or discipline to reach workable, consistent and competent solutions to achieve successful performance of every or whatever activity to be conducted to avoid possible delays. I repeat, It can be plainly said, clearly said, openly said, without any hesitation, without any reservation, that engineering coordination is an only formula, only discipline, sub-discipline, only answer to reach workable, consistent and competent solution, consistent solution, workable solution, practical solution, adaptable solutions to achieve successful performance. To achieve successful performance of every activity, I'm sorry I've written our activity wise missing, every activity to be conducted to avoid possible delays. So that's what my mind thinks of, and we go to concrete. That is, it's almost, I think, 1 hour. Yes, almost one. Then we talk the pre-stressing wires and strands should conform to whatever this says. Okay, now we go to structural steel. Let us say what it says. The structural steel should conform to this. All right, what commentary says. Let us understand this. Rolled steels for general structures specifies for 4 types of rolled steels. In this SS330, SS400, 490. Okay, that is class. We can have separate discussion on that. Chemical constituents, mechanical properties. We have to consider chemical constituents of structural steel, and we have to see mechanical properties, and we should see shapes. So these are very important point. Dimensions and mass and allowances. Similarly, rolled steel for welded structures, rolled steels for welded structures specifies for 11 types of rolled steels, ranging from it is SM400A to SM570, and this is Japanese. So rolled steels for building structures, called rolled steels for building structures, that has been standardized in 96, specifies for heated rolled steel that is used mainly for steel made structures of buildings. Heated rolled steel, not cold rolled steel. Heated rolled steel that has used mainly for steel made structures of buildings. These specifications described in each standard may be considered to be quality of rolled steels. Mechanical properties include yielded strength or load carrying capacity, yielding strength or load carrying capacity, tensile strength, elongation and inner radius of bent over. Steel bars for steel reinforced concrete structure are in principle selected on basis of its yielded strength, similar to that of reinforcement bar used together. Then other reinforcing steels are quality of other reinforcing steel shall be appropriately confirmed and carried, and careful attention paid to method of using them. There are many reinforcing materials. There are many reinforcing materials other than those mentioned, for which there exists yet no quality standard. There are many types and many methods using them. When using those reinforcing materials, it is necessary to conduct thorough studies and tests to ascertain quality and identify methods for using those materials. There are cases where reinforcing materials composed partially of fibers are used with aim of achieving higher quality of hardened concrete. But says there are cases where reinforcing materials composed partially of fibers are used within concrete to achieve higher quality hardened concrete, preventing spalling of concrete used in tunnels, can say used in tunnels or other structures. Fibers used in such cases can be largely classified into two categories: short fibers and continuous fibers. Examples of short fibers are inorganic fibers. Short fibers are inorganic fibers, not organic, inorganic chemistry. Fibers including metal fibers such as steel fibers and stainless steel fibers, both steel fibers and stainless steel fibers. Glass fibers, carbon fibers and ceramic fibers. So celluloses are metal fiber, metal means steel fibers or stainless steel fibers, glass fibers, carbon fibers, ceramic fibers. Also organic fibers such as aramid, organic, now we are talking, not inorganic. Organic such as aramid, nylon, aramid, nylon, vinylon, polythene, polythenes are organic, It's aramid, it's nylon, it's vinylon, it's polyethylene and polypropylene. Polyethylene, polyethylene PE and polypropylene, ethylene and propylene, polyethylene and propylene, and it has also organic fibers such as aramid, nylon, vinylon, polyethylene and polypropylene. When when using short fibers, it's good practice to conduct tests in advance to check on quality of fibers to be used, because suitable diameters, lengths and shapes vary with intended use of fibers. Standard for quality of steel fibers for concrete can be used as a guide for quality of steel fibers. Concerning production of short fiber reinforced concrete, construction is that special concrete of this specification, that is chapter 5 ke leave it now. Continuous fiber reinforcing materials. Continuous fiber reinforcing materials are continuous, continuous fiber reinforcing materials are continuous fibers cemented either into bars to be used as substitutes for steel bars, or pre-stressing tendons, or into shades. Now former are used mainly as concrete reinforcing or tensioning members, while later used for repair or reinforcement of concrete. There are 5 types of fibers used in continuous fiber reinforcing materials. There is carbon fibers, aramid fibers, glass fibers, nylon fibers, and their mixtures. Continuous fiber reinforcing materials can also be broadly classified according to shapes into 5 types: rod, strand, braid, mesh, and rectangular plate. That is rod, we call it bar, strand, braid, mesh, and rectangular plate, because material shape, quality, and other characteristics of continuous fiber reinforcing materials vary widely among different types. It's recommended that standard conforming tests be conducted in advance as case of steel fibers to verify quality. It is also when producing continuous fiber reinforced concrete, it's good practice to refer to construction. Alright, so we have here, one is rod, one is strand, braid, and we have to also battery if I explain to you further, because I don't know Hindi meaning of that, and that's a problem. So you can say braid, and was that was It was actually it says strand and braid. So let us see what is strand. Let us see strand meaning in English. Strand meaning is left in a place that is stranded. We call it stranded, left in a place that you cannot get away from. असहाय संकटग्रस्त बेवसारी ऐसे स्थान पर फंसा हुआ जहाँ से निकलना मुश्किल. That is stranded. That's okay. We know that meaning in comprehension stranded. I mean फंसे हुए. You can say फंसे हुए. In Hindi we can call it this stranded, and also we call it braid. What was the braid? B-R-A-I-D, I think. B-R-A-I-D, braid meaning is, and what's meaning of braid? Is braid. Thin colored rope that is used to decorate military uniform. Braid. सैनिक पोशाकों में प्रयुक्त सजावटी फीता. Okay. And braid definition is to weave together strips or strands of the form by such weaving. So we got that point. What is braid? And this was just something to explain in common terms. And I say, so we have here, so you can say that is rod, strand, braid, mesh, and rectangular plate. So we know that. We got it. Because material shapes, we have gone through that. Now continuous fiber reinforcing materials. You can say, he said, because material shape, quality, and other characteristics of continuous fiber reinforcing materials vary widely among different types. Therefore, we have to say standard conforming tests be conducted in advance, as in case of steel fibers, to verify quality. Also, when producing continuous fiber reinforced concrete, it's good practice to refer to construction. Now, continuous fiber reinforcement, reinforcing materials, that is continuous fiber reinforcing materials are easily damaged when placed directly on ground. When continuous fiber reinforcing materials are easily damaged when placed directly on ground or floor surface and are subject to quality degradation. Furthermore, continuous fiber reinforcing material may deteriorate depending on type of fiber. If placed at a place exposed to high temperature or ultraviolet rays or under influence of chemicals or says, let's repeat it, it's important. Continuous fiber reinforcing materials are easily damaged when placed directly on ground or floor surface and subject to quality degradation. Furthermore, continuous fiber reinforcing materials may deteriorate. That is, furthermore, continuous fiber reinforcing materials may deteriorate depending on type of fiber. If placed at a place exposed to high temperature, or ultraviolet rays, or under influence of you can say chemicals when storing continuous fiber reinforcing materials. Therefore, it's necessary to protect them from those influences. Now, storage of cement, storage of materials, we're talking of storage of cement. Let's say different types of cement shall be stored separately. Different types of cement shall be stored separately. And let me go for that. So here is what I say. Here's a simple, yeah. Different types of cement shall be stored separately in damp-proof silos. Where should be no dampness? Damp-proof silos, warehouses, or other storage facilities. Silos be designed so that there exists no dead storage area near bottom of storage space. When cement has been stored for a long period of time, cement shall be tested to ascertain its quality prior to its use. When temperature of cement is excessively high, when temperature of cement is excessively high, temperature of cement shall be lowered prior to use. Now some comments, let's read in this. When in, you can say when in contract, when in contact with air while in storage. When in contact with air while in storage, cement undergoes light hydration. Light hydration by absorbing moisture from air. You have to think this way. When it is in contact with air while storage, cement undergoes light hydration by absorbing moisture from air and simultaneously reacts with carbon dioxide. So it's very simple. When it is in contact with moisture from air, it undergoes light hydration by absorbing moisture from air, simultaneously reacts with carbon dioxide in air. Means moisture in air and simultaneously reacts with carbon dioxide in air. This process is referred to weathering of cement. weathering. Processes refer to weathering of cement. As cement weathers, ignition loss increases. As cement weathers, ignition loss increases and density decreases, so that setting is delayed or strength decreases with progress of weathering. It's necessary, therefore, not only to keep moisture away from cement, but also to store cement in an unventilated conditions. If cement is stored in a highly airtight silo designed to prevent internal condensation, quality of cement hardly changes, even if cement is stored for a relatively long period of time. It's desirable that capacity of a silo be equal to or greater than 3 times average quantity of cement used in one day. It is desirable that capacity of a silo be equal to or greater than 3 times average quantity of cement used in one day. If cement can be supplied smoothly because there is a concrete mixing plant at a relatively short distance from cement service station, silo capacity can be made smaller. If bags of cement are stored for a relatively long period of time or during a high humidity period, it's good practice to take weathering prevention measures, such as using bags lined with damp-proof membrane. In order to protect bags of cement in storage from moisture from ground. Warehouse floor needs to be kept a sufficient distance away from ground. In case of a wooden warehouse, for example, 30 centimeter is required. In order to protect cement in storage from condensation due to rain or difference between internal and external temperature, it's important to stack bags of cement so that they do not come into contact with warehouse walls. If bags of cement are stacked while in storage, cement in lower bags might consolidate. A recommended time limit to number of layers of stacked bags of cement, therefore, is about 13. Cement silos should have features or provisions to prevent occurrence of dead storage. Cement silos have features should have features or provisions to prevent occurrence of dead storage. Areas where stored cement does not flow out of is stunk. Cement silos should have features or provisions to prevent occurrence of dead storage. Areas where stored cement does not flow out of is stuck, such as non-symmetrical structure. A steep bottom cone to facilitate flow or vibrators or aerators facilitate flow movement. It's also necessary to inspect and clean silos at appropriate frequencies. Needless to state, cement containing lumps. It is, you can say, needless to state, cement containing lumps formed while cement is stored. Cement storage must not be used. Cement containing lumps formed while cement is stored, it must not be used. In case of cement that may have been exposed to moisture because of storage over a long period of time, it's necessary to conduct tests, that is mortar tests, and evaluate usability of cement. As temperature of cement changes by 8 degrees Celsius, as mixed temperature, concrete rises or falls by 1 degree Celsius. Is this way? As temperature of cement changes by 8 degrees Celsius, as mixed temperature, concrete rises or falls by 1 degree Celsius. The relation of 8 degree to 1 degree means if temperature of cement changes by 8 degrees, this means as mixed temperature, concrete rises or falls by 1 degree Celsius. Influence of cement temperature on concrete temperature is smaller. Influence of cement temperature on concrete temperature is smaller than influence of aggregate and water. If, however, cement with an excessively high temperature is used, as mixed temperature of concrete may rise so as to cause abnormal consolidation or a decrease in slump. It may be necessary, therefore, influence of cement temperature on concrete temperature is smaller than influence of aggregate water. If, however, cement with an excessively high temperature is used, as mixed temperature of concrete may rise so as to cause abnormal consolidation or decrease in slump. It may be necessary, therefore, to impose limits on cement temperature at time of shipping from a factory or at time of delivery. At construction site, or says, if, however, cement with an excessively high temperature is used, as mixed temperature of concrete may rise so as to cause abnormal consolidation or a decrease in slump. It may be necessary, therefore, to impose limits on cement temperature at time of shipping from factory or at time of delivery at construction site. It may be necessary, therefore, to impose limits on cement temperature at time of shipping from factory or at time of delivery at construction site. Temperature of delivered cement varies with transportation route from cement factory and time of year. For example, average temperature of cement shipped directly from cement factory ranges from 50 to 80 degrees Celsius. That is very important point to understand. Average temperature of average temperature of cement average temperature of cement shipped directly from a cement factory ranges from 50 to 80 degrees Celsius. If cement is transported by ship or stored at a service station, if cement is transported, for example, average temperature of cement shipped directly from a cement factory ranges from 50 to 100 degrees Celsius. If cement is transported, by ship or stored at a service station, cement temperature tends to be slightly lower. In general, no problem arises if cement with a temperature of 50 degrees Celsius or lower is used. Or says in general, no problem arises if cement with a temperature of 50 degrees Celsius or lower is used. Storage of aggregate. Storage of aggregate. Storage of aggregates. Storage of aggregate and fine aggregate and coarse aggregate and aggregate of different types. Fine, coarse and aggregate of different types from different places of origin or of different particle sizes shall be isolated and stored separately. Aggregate shall be received. Aggregates shall be received, stored, and handled carefully. Aggregates shall be received, stored, and handled carefully by using machinery and equipment of appropriate structure in order to prevent problems such as separation of large and small particles, inclusion of foreign matter, and damage to coarse aggregate. Aggregate shall be received, stored, and handled carefully by using machinery and equipment of appropriate structure in order to prevent problems such as separation of large and small particles, inclusion of foreign matter, and damage to coarse aggregate. Aggregate storage facilities shall be provided with appropriate drainage facilities so that surface moisture conditions become uniform. In time of cold weather, aggregate shall be stored by use of appropriate facilities to prevent inclusion of ice and snow and freezing. Time of cold weather conditions, aggregate shall be stored by use of appropriate facility to prevent inclusion of ice and snow freezing. Aggregate shall be stored by use of appropriate facilities to, for example, keep cement away from direct sunlight. Aggregate shall be stored by use of appropriate facilities to, for example, keep cement away from direct sunlight in order to prevent aggregate from drying and temperature from rising under hot weather. Now what's comments we have? In order to produce concrete of consistent quality, it is necessary to make sure that quality of aggregate used is always consistent. Different types of aggregate such as gravel, sand, crust stone have gravel, sand, crust stone, blast furnace slag aggregate, and lightweight aggregate. Lightweight aggregate, blast furnace aggregate, lightweight aggregate, aggregate of different particle sizes or maximum particle sizes, aggregate that has been graded in advance, and like must be isolated from one another by using appropriate dividing devices and be stored separately. If particle sizes of coarse aggregate fall, if particle sizes of coarse aggregate fall within range of 20 to 55 mm, so it says things. If particle sizes of coarse aggregate fall within range of 20 to 5 mm, it is good practice to divide aggregate into two classes, namely 20 to 10 mm and 10 to 5 mm, and store them separately. Similar care be taken in accordance in connection with so yes, and 10 to 5 mm and store them separately. Similar care needs to be resorted to in accordance in connection with receiving of delivered aggregate and handling of in order to prevent segregation of aggregate, it was here before. I think similar care needs to be taken in connection with receiving of delivered aggregate and handling of aggregate from storage area to mixing area. In order to prevent prevent a segregation of aggregate, it is necessary to take preventive measures such as avoiding a sloping area where aggregate rolls down. One way to prevent inclusion of foreign matter is to store aggregate on a concrete floor and surround storage area with trenches or walls. Trenches. Care should be taken to make sure that mud and other foreign materials, foreign sticking to tires. One only way to prevent inclusion of foreign materials is to store aggregate on a concrete floor and surround storage area with trenches or walls. Care should be taken to make sure that mud and other foreign matter sticking to tires of aggregate hauling vehicles is not mixed into aggregate. Shovel is not mixed into aggregate. Shovel loaders with rubber tires should be used to handle aggregate because crawler mounted loaders could request that. So we have here to see shower loaders with rubber tires should be used to handle aggregate because crawler mounted loaders crush aggregate and wear wear concrete floor, top feed, bottom discharge silos are recommended. Top feed, what is said? Wear concrete floor, top feed, bottom discharge silos are recommended. Percentage of battery is 50%. And then we say in cases, you can say in cases where blast furnace slag aggregate. In cases where blast furnace slag aggregate is or lightweight aggregate is stored, it is desirable to install that watering devices shall be sprinklers. Water devices such as sprinklers as well as drainage facilities be provided. The reason is that because pumping of concrete has increased in recent years, in case of blast furnace slag aggregate or lightweight aggregate, both are more absorptive than gravel and crushed stone. Slump of concrete may decrease considerably during pumping if water is not spread to some extent in advance. So we say in case where blast furnaces slag aggregate or lightweight aggregate is stored, it is desirable that watering devices such as sprinklers as well as drainage facilities be provided. Reason is that because pumping of concrete has increased in the case of blast furnaces, slag aggregate or lightweight aggregate, both of which are more depth absorptive than gravel and crushed and some extent irreversible. If gravel and crushed stone slump of concrete may decrease considerably during pumping if water is not sprayed to some extent in advance. A frozen aggregate or aggregate containing ice or snow is used as under cold weather. Temperature of concrete may decrease so that concrete freezes or water content increases in order to prevent the intrusion of ice and you can say snow. Therefore, it's important to cover aggregate with something or store aggregate in roofed storage facility. If aggregate that has been exposed to if aggregate that has been exposed to backing heat under hot weather, if backing, you can say, if aggregate that has been exposed to backing heat under hot weather for a long period of time, is used, concrete temperature may rise. If this occurs, workability may change considerably while concrete is being transported or handled, or consolidation may be extremely accelerated. Concrete is being transported or handled, or consolidation may be extremely accelerated, so that satisfactory construction work cannot be carried out. What it says, what happens if for long period of time aggregate lies in hot weather, it may give rise to concrete temperature, and if it occurs, workability of concrete may change, and considerably while concrete remains transported, concrete is being transported or handled, or consolidation may be extremely accelerated, or consolidation may be extremely accelerated, so that satisfactory construction work cannot be carried out. In order to prevent this problem, it's important to provide appropriate coverings of water spraying facilities at places where aggregate is stored. If blast furnace slag fine aggregates to be stored for a long period of time, during a period in which daily mean temperature exceeds 20 degrees Celsius. A blast furnace slag fine aggregate is to be stored for a long time during a period in which daily mean temperature exceeds 20 degrees Celsius. It's necessary to pay careful attention to organizational management of storage. Case of cylindrical silo made of corrugated metal. In case of cylindrical silos made of corrugated metal, members or other materials that greatly increase work. You can say in case of cylindrical silos made of corrugated metal, members or other materials that greatly reduce work efficiency. In the event of consolidation onto silos should be designed to prevent occurrence of near bottom dead storage. Silos should be designed to prevent occurrence of near bottom dead storage, areas from which stored aggregate cannot be extracted, and attention should be paid to level of consolidation control. Storage of admixture. Storage of admixture. Different types of admixtures shall be stored separately in damp-proof silos, warehouses, or other storage facilities. When an admixture has been stored for a long period of time, is used, admixture shall be tested to ascertain its quality prior to use. Admixture shall be tested to ascertain its quality prior to use. Admixtures shall be handled carefully so that they are not scattered about. Admixtures are usually absorptive. And an admixture that has absorbed moisture may consolidate or deteriorate in performance, so that required quality cannot be achieved. Example is fly ash consolidates when a very small amount of gypsum contained in fly ash absorbs moisture. Fly ash consolidates when a very small amount of gypsum contained in fly ash absorbs moisture. And silica fume, which is very fine grained, is more absorptive than other admixtures and is therefore prone to consolidation. Because expensive admixtures for concrete can contain a large quantity of free calcium oxide. So because why? No. Because expensive admixtures for concrete contain a large quantity of free calcium oxide. They're more prone to weathering than cement. If different types of admixtures are mixed together, it may not be possible to attain expected effect. It's therefore necessary to separate different types of admixtures and store them separately in damp-proof silos, warehouses, or other storage facilities. Bagged, canned, bagged, canned, or otherwise packed, as packaged admixtures must be stored so that packages are not broken or damaged, can be easily identified and inspected. It's therefore necessary to separate different types of admixtures and store them separately in damp-proof silos, warehouses, or other storage facilities. Bagged, canned, or otherwise packaged admixtures must be stored so that packages are not broken or damaged and can be easily identified and inspected. If admixtures are stored for a long period of time, quantity of admixtures may change, quality of admixture may change even if these are carefully stored. Therefore, storage period has become long. Usability of admixture must be evaluated after conducting a test again and ascertaining degree of influence of long storage period on concrete. Powdered admixtures tend to be scattered. Powdered admixtures tend to be scattered about in bag, by like splitting areas and around silo outlets so as to cause measuring instruments to break down. During the humid periods, scattered powder tends to stick to surfaces of silos and transportation equipment. It's important, therefore, to carefully handle powdered admixtures so that powder is not scattered about. It may also be necessary to provide dust control equipment. Storage of chemical admixtures. I think 1.5 hours it. Temperature is facility is 37, so I should put it on 37. It's quite logical to put that on, otherwise it will cause a problem. Storage of chemical admixtures. Let me see time now. So I think I'm 1.5 hour, maybe 1.5 hour is right. 1:44. Okay, 10 minutes more I go. That's the best I can say. Yeah. So we can say chemical Storage of chemical admixtures. Chemical admixtures. Chemical admixtures shall be stored so that impurities such as waste materials, are not mixed into admixture. Liquid chemical admixture shall be stored so that neither segregation nor alteration results. Chemical admixture shall be stored so that impurities such as waste materials are not mixed into admixture. Liquid chemical admixture shall be stored so that neither segregation nor alteration results. Powdered chemical admixtures shall be stored. Powdered chemical admixtures shall be stored so that they do not absorb water, moisture, or consolidates. Chemical admixtures that have been in storage for a long period of time or that have been found to be in anomalous condition. Anomalous condition be tested prior to use to make sure that performance had not deteriorated. Chemical admixtures that have been in storage for a long period of time that have been found to be in anomalous conditions be tested prior to use or make sure that the performance had not deteriorated. Impurities. Impurities such as waste materials. Talking of impurities, impurities such as waste materials can say impurities such as waste materials in a chemical admixture may alter quality of chemical admixture, so that you can say, why this opening? Let me close it. Okay, so impurities such as waste material in a chemical admixture may alter quality of quality of chemical admixture, so that expected effect cannot be achieved. In case of chemical admixture that's used in very small quantities, such as air and training agent, impurities could hamper accurate measurement of required quantities. This is in case of a chemical admixture that is used in very small quantities, such as an entraining agent. Impurities could hamper accurate measurement of required quantities. Impurities in a liquid chemical admixture could cause malfunctioning of feed pumps or instrument valves. When storing chemical admixtures, therefore, it's necessary to exercise due care to prevent inclusion of waste materials and other impurities. In case of a liquid chemical admixture, not only inclusion of impurities but also changes in concentration. In case of liquid chemical admixtures, not only inclusion of impurities but also changes in concentration due to evaporation of moisture or intrusion of rainwater can be prevented by storing admixture in a closed tank. Let's say in case of liquid chemical admixture, not only inclusion of impurities but also changes in concentration due to evaporation of moisture or intrusion of rainwater can be prevented by storing admixture in a closed tank. Repeat, it's an important point. Again I say, when strong chemical admixtures, therefore it's necessary to exercise due care to prevent inclusion of waste materials and other impurities. In case of liquid chemical admixtures, not only inclusion of impurities but also changes in concentration due to evaporation of moisture or intrusion of Rainwater can be prevented by storing admixture in a closed tank. When different types of chemicals admixtures are stored, it's necessary to exercise due care so as not to use same containers for more than one type of chemical admixture. When different types of chemicals admixtures are stored, it's necessary to exercise due care so as not to use same container for more than one type of chemical admixtures, or inadvertently mix different types of chemical admixtures. When a chemical admixture freezes, when a chemical admixture freezes, segregation of ingredients occur. Segregation of ingredients occurs. It's therefore necessary in winter to take measures to prevent chemical admixtures from freezing. It's in many cases possible. However, to restore performance of a chemical admixture, it has undergone segregation because of freezing by completely melting and remixing frozen admixture. Powdered chemical admixtures are highly hygroscopic. Powdered chemical admixtures are highly hygroscopic, and certain types of powdered chemical admixtures are deliquesce, hygroscopic and deliquesce. These types of chemical must be stored in damp-proof ventilated storage facilities. Hygroscopic and deliquesce. Let us also understand this term clearly, because terminology is very important. Hygroscopic, meaning of it, but let me put that. Hygroscopic meaning tending to absorb moisture from air. That is hygroscopic. And says tending to absorb moisture from air related to the humidity of its mixture. And hygroscopy. Hygroscopy is a phenomenon of attracting and holding water molecules via either absorption and hydroscopy. Let me explain hygroscopy. So clear, everyone. It's important to clear first. Then hygroscopy is phenomenon of attracting and holding water molecules via either absorption or adsorption from surrounding environment, which is usually at normal or room temperature. If water molecules become suspended among substance molecules, absorbing substances can become physically changed. Change in volume, boiling point, viscosity, and some other physical characteristics so we have to see this phenomenon affecting holding water molecules with hygroscopy by absorptions from surrounding environment is usually at normal or room temperature. The water molecules become suspended among substances molecules absorbing substance can form an aqueous solution. I'm not going to talk much on this. This is terminology I try to guide for you. And then there's another one is hygroscopic. Another one is deliquesce, deliquesce. Let us what's that deliquesce, and we can say this deliquesce is. What is the deliquesce? Deliquescy. Deliquescy. Spelling is different. That is Where's that? Where's the high answer types of that? DELIQUESCE. You know this one, deliquesce. Oh no, deliquesce. Deliquesce. Deliquesce is organic matter become liquid. Typically during decomposition it becomes liquid by absorbing moisture. So deliquesce. If you get it that gets moisture, it becomes unsolid. So this is that. So is may say become liquid after getting moisture. That is meaning of delicacy. So dissolve, melt away. Someone enormous is now we got this in coming in contact with moisture, it becomes liquid. So that's what is deliquesce and liquefies. These types of chemical admixtures must be stored in damp-proof unventilated storage facilities. In view of these factors, when storing chemical admixtures, it's necessary to take meticulous preventive measures such as shielding sunlight, keeping fire away. So, keeping fire away. If chemical admixtures are stored for a long period of time, you can say, if chemical admixtures are stored for a long period of time, quality of admixtures may change, even if they are carefully stored. Storing a liquid chemical mixture for a long period of time may result in not only segregation but also decomposition or alteration due to rust forming in iron containers. Storing a liquid chemical admixture for a long period of time may result in not only segregation but also decomposition or alteration due to rust forming on iron containers. If chemical admixtures are stored for a long period of time, quality of admixtures may change even if they are carefully stored. Storing a liquid chemical admixture for a long period of time may result in not only segregation but also decomposition or alteration due to rust forming and on iron containers. Evaporation of moisture may result in a higher concentration and solidification of surface layer. If therefore chemical admixtures have been stored for a long period of time, when found to be anomalous solution conditions necessary to evaluate influence of concrete by testing them again and determine whether they can be used even if quantity of chemical admixture is small. Its influence on concrete is great. Care must be taken because even a small change in quality of concrete mixture, chemical admixture may change, but a significant difference in quality of concrete. I think this point we should be a little typical. It is better to understand. I'll give a few minutes. I'll be back this time, and I'll be back a couple of minutes. Meanwhile, you can go ahead with this. Sorry, gentlemen. Yes, again, I think you have done it. I think got it. Any chemical. So we was talking about something like that, and it was about when a chemical admixture physics segregation of ingredients occurs. Is therefore necessary in winter to take measures to prevent chemical admixtures from freezing. It's in many cases possible, however, to store performance of a chemical admixture that has undergone segregation because of freezing by completely melting and remixing frozen admixture. Powdered chemical admixtures are highly hygroscopic, and certain types of powdered chemicals admixtures even deliquesce. These types of chemicals admixtures must be stored in damp-proof, unventilated storage facilities. In view of these factors, when storing chemical admixtures, it is necessary to take meticulous preventive measures such as shielding sunlight, keeping fire away, and preventing freezing. If chemical admixtures are stored for long period of time, if chemical admixtures are stored for long period of time, quality of admixtures may change even if they are carefully stored. For example, storing a liquid chemical admixture for a long period of time may result in not only segregation but also decomposition or alteration due to rust forming on iron containers. Evaporation of moisture may result in a higher concentration and solidification of surface layer. I repeat, it says if chemical admixtures are stored for a longer period, quality of admixtures may change even if these are carefully stored. Storing a liquid example is storing a liquid chemical admixture for a long period of time may result in not only segregation but also decomposition, alteration due to rust forming of iron containers. Evaporation of moisture may result in higher concentration and solidification of surface layers. Therefore, chemical admixtures may have been stored. Therefore, chemical admixtures have been stored for a long period of time or have been found to be in anomalous condition. If therefore chemical admixtures have been stored for a long period of time or have been found to be in anomalous condition, it's necessary to evaluate influence on concrete by testing them again and determine whether these can be used. Even if quantity of chemical admixture used is small, influence on concrete is great. Care must be taken that because even a small change in quality of chemical admixture may result in a significant difference in quality of concrete. And we are now storage of steel. Reinforcing bars and structural steel shall be supported at appropriate spacing and stored in storage facilities or if stored outdoors under appropriate cover instead of being placed directly on ground surface. pre-stressed steel shall be supported at appropriate spacing and stored in storage facilities or, if stored outdoors, under appropriate cover for protection from harmful substances such as oil, chlorides, and waste materials, and harmful processes and effects such as corrosion, damage, and deformation. Reason why steel reinforcement bars and structures must not be placed directly on ground surfaces that need be protected from rusting or contamination. Reason why reinforcing bars and structures are stored in storage facilities are under the appropriate covers that corrosion of reinforcing bars and structural steel due to rain, condensation, corrosive, salt, air, etc. needs to be prevented when storing steel reinforcing bars and structural steel. It's necessary to support them with appropriate spacing for easy handling and convenience in inspection. Steel reinforcing bars and structural steel of different material types should be stored separately. Steel reinforcing bars and structures of different metal types should be stored separately. Steel reinforcing bars of different diameters and structural steel items of different cross-sectional shapes and diameters should be stored separately. When storing pre-stressing steel, it's necessary not only to be as careful as with steel reinforcing bars and structural steel, but also to make special arrangements. Reason why pre-stressing steel must not be placed directly on ground surfaces that's necessary not only to prevent crusting and corrosion due to moisture and prevent borrowed metal such as oil, waste and materials and mud from sticking to pre-stressing steel, but also to make handling of pre-stressing steel easier. Reason why pre-stressing must be stored in storage facilities or on the appropriate cover is that rusting and corrosion due to rain, condensation, corrosive, salt, air need be prevented. Pre-stressing steel requires careful attention because oil, waste materials, mud, etc. sticking to steel surfaces may cause steel, concrete bond strength to decrease. Because threaded portions of steel items are particularly prone to strength loss due to corrosion. Because threaded portions of steel items are particularly prone to strength loss due to corrosion, they must be stored so that they are perfectly protected from corrosion. If coils of pre-stressing steel wires and pre-stressing steel strand are stacked in multiple layers for storage, harmful flexural loading from upper coils may cause stress-induced corrosion. It is therefore necessary to take such measures as restricting number of stacked layers in case of pre-stressing steel wire and pre-stressing steel strand, which are shaped in form of coils. Property of restoring linearity when unwound is important from viewpoint of efficiency on construction. In order to prevent wire or strand from being bent, so that their ability to return to original shape is lost, it is desirable that coil diameter be kept at greater than 150 times the diameter of steel wire or strand. In order to prevent wire or steel strand from being bent, so that ability to return to original shape is lost, it is desirable that coil diameter be kept at or greater than 150 times the diameter of steel wire or strand. Quality of pre-stressing steel may be altered if it is heated to about 300 degrees Celsius. Quality of pre-stressing steel may be altered It's heated to about 300 degrees Celsius or higher, care must be taken. Therefore, keep pre-stressing steel away from fire. Mixed design. Mixed design. General. In mixed design, unit quantities shall be determined after specifying mix requirements such as slump, required strength, and water cement ratio of concrete, so that workability, strength, and durability requirements can be met. Concrete mix proportion shall be determined by minimizing water content in order to meet performance requirements. Now this describes a method for determining concrete mix proportions to meet three performance requirements. Those are workability, specified strength, and durability. Mixed design methods described are applicable to concrete whose specified strength is about 60 Newton per millimeter square or lower, and whose workability in a fresh state is evaluated in terms of slump. In cases where concrete is to be placed under unusual conditions, such as when placing concrete to constructed spaces or through densely packed reinforcing steel, or when placing a new layer of concrete under a previously placed layer of concrete, inverted construction method. What it says, when placing a new layer of concrete under a previously placed layer of concrete, inverted construction method, high fluidity concrete with self-compacting ability should be used. Mixed proportions for high fluidity concrete, self-compacting concrete shall be determined as described in special concrete section. Next, 7th chapter. If concrete with a slump of 21 cm or less, slump of 200 mm or less is inadequate in terms of filling ability, but performance as high as that of high fluidity concrete is not necessary. It says, if concrete with a slump of 21 cm or less is inadequate in terms of filling ability, but performance as high as that of high fluidity concrete is not necessary, mixed proportions somewhere in between should be selected under guidance of an expert well versed in concrete mix design and construction technology. When designing concrete mixes, it is necessary not only to meet requirements for specified strength necessary for purpose of structural design and durability requirements, but also to select mixed proportions that ensures workability, mixed proportions that ensure workability is suitable for structure and construction requirements for structure to be constructed. I repeat, when designing concrete mixes, it's necessary not only to meet requirements for specified strength necessary for purpose of structural design and durability requirements, but also to select mixed proportions that ensure workability suitable for structural and construction requirements for structure to be constructed. Design drawings and specifications indicate ranges of reference values, namely maximum size of coarse aggregate, slump water cement ratio, type of cement, cement content, to be reflected in actual mixed designs, derived on basis of verification of structural performance durability of various types, watertightness, cracking resistance, steel protection performance. Mixed design in this writing chapter therefore is act of determining unit quantities of various materials, including water content, suitable for materials to be actually used at construction stage, and construction requirements on basis of reference values indicated on design drawings and specifications mentioned above. Now this figure illustrates the concept of concept for determining mixed proportions. To meet workability specified strength and durability requirements for concrete. Workability, which is an indicator of ease of construction by use of concrete. Workability, which is an indicator of ease of construction by use of concrete, is a performance attribute required for ensuring smooth and reliable execution of a series of tasks including placing, compacting, and finishing. This chapter focuses mainly on ability of concrete to smoothly pass through space between reinforcing steel and completely fill concrete cover regions. Corners in formwork and pre-stressed concrete anchorage joints. Filling ability without undergoing segregation of ingredients. Filling ability is performance attribute. Filling ability is a performance attribute determined by interaction between fluidity and segregation resistance. Interaction between fluidity and segregation resistance. In order to obtain concrete with satisfactory filling ability, it is necessary to provide appropriate segregation resistance according to fluidity. Fluidity and segregation. Fluidity and segregation resistance are affected by not only water content, binder content, and water binder ratio, but also other factors such as type of powder used, particle sizes, and shapes of fine and coarse aggregate, type of chemical admixture. In construction standards, slump is used as an indicator of fluidity in view of practical convenience. In general, segregation resistance is numerically expressed with rheological constants such as plastic viscosity and yield value. Since, however, segregation resistance can be controlled with relative ease by increasing or decreasing binder content. Binder content is used as practical indicator of segregation resistance. Basic mixed design approach to be taken in order to achieve desired performance of concrete is to use a water cement ratio not higher than ratio indicated in design specifications. Cement content is also not higher than upper limit indicated in design specifications. Water content should be minimized to extent that binder content required to achieve complete and smooth filling is secured. In mixed design, it's also very important to achieve appropriate segregation resistance by increasing or decreasing binder content according to slump instead of simply increasing or decreasing water content according to specified slump. I repeat, in mixed design, let me read the whole para. Basic mixed design approach to be taken in order to achieve desired performance of concrete to use water cement ratio not higher than ratio indicated in design specifications. Cement content is also not higher than upper limit indicated in design specifications, and water content should be minimized to extent that binder content required to achieve complete and smooth filling is secured. In mixed design, it's also very important to achieve appropriate segregation resistance by increasing or decreasing binder content according to slump instead of simply increasing or decreasing water content according to specifications. The figure illustrates concept of mixed proportion in case where cement content indicated in design specifications is lower than binder content. Says concept of mixed proportion in case where cement content indicated is in design specifications is lower than binder content needed to achieve required filling ability. Case may occur when it is desired that cement content be lowered as much as possible in order to minimize heat generated by hydration, as in case of mass concrete or massive block concrete. With this cement content, however, excellent filling ability from reviews of workability cannot be achieved. Let's say, however, excellent filling ability from viewpoint of workability cannot be achieved. It's necessary to use concrete of types generates a small quantity of heat. It's necessary to use concrete of type generates a small quantity of heat, or blended cement or use admixtures. So limestone powder. Use admixtures such as limestone powder in order to increase powder content to level required to achieve required filling ability. Here is what you say concept of mixed proportioning in normal case. You can see horizontally x-axis is lower limit of binder content, and this is binder content graph. On lower x-axis is binder content. This lower limit of binder content is indicated by arrow, that is here, and it is lower limit of binder content, that is this one, required from viewpoint of workability, and this is binder content. And if you see y-axis, that is water content. Upper limit of water content is here, and lower limit of water content required from viewpoint of workability is here. So this is water content upper limit, this is lower limit from viewpoint of workability, and this is binder content itself lower limit, and binder content comes on this. Now these lines we will join here with the water cement ratio determined by strength and durability. That is this much water cement ratio determined by strength and durability. Sorry. And there is upper limit of cement content determined by durability and high heat of hydration, and that's here. And here is some gray area. You can say mixed proportions are to be selected from this area. So this is binder content, and this is here water content, water binder content. You can say this is water content and this is binder content, or you may say like this uses water cement the same, and this is your cement content determining upper level of cement content determined by durability and heat of hydration. So this here I can say is going increasing, and this is here upper limit of cement content that is the durability is this is upper limit and this is lower limit, and this is upper limit of water, and this is square chord like this. This is binder content or cement content, you may say. That's the upper limit is this, lower limit is this. In this lower limit and upper limit, There's lower limit of water content, it's lower limit of water content, it's higher limit of water content, and this portion, these mixed proportions are to be selected from this, and that is from here we have to take binder content, and we have to take in this region binder content as was water content. So this was the concept of mixed proportioning in normal case. So again I say here is this graph is binder content, this graph is water content, and you can say this is upper limit of water content, this lower limit of water content, and here is lower limit of binder content, that is water content upper limit and lower limit, and here is binder content upper limit, this is lower limit, this is upper limit. So by both lower limits and upper limits we got portion here. Below this line, upon a line, what is a line, and this is mixed proportions are to be selected from this area. And this concept of mixed proportion in case where provided content is too low from view point of filling ability, that was the high one, it was for low. Yeah, see that. Same thing stands here, only difference is upper level water content, lower level, and this is your lower limit, and this is your higher limit. Increased binder invariant, that is increasing binder invariance such as cement, and this way, and there's water here, and say mixed portions are from this portion. So it's same as usual, only difference is that this is your this is lower limit, upper limit of cement content, and this is upper limit here, this is lower limit here, and we have to say in almost all ordinary concreting projects, ready mix concrete is used. That's right. In almost, you can say, in almost all ordinary concreting projects, ready mixed concrete is used. Even in such cases, it is important to select mixed proportions on basis of mixed design methods described in this chapter and select appropriate mixes from available types of ready mix concrete with reference to mixed proportions thus selected. So we say in almost all ordinary concreting projects, ready mix concrete is used. Even in such cases, it is important to select mixed proportions on basis of mixed design methods described in this chapter and select the appropriate mixes from available types of ready mix concrete with reference to mixed proportions thus selected. A high water content not only makes uneconomical concrete. A high water content not only makes uneconomical concrete that requires a high cement content to achieve same water cement ratio, but also makes concrete prone to segregation. A high water content not only makes uneconomical concrete but requires a high cement content to achieve same water cement ratio, but also makes concrete prone to segregation so as to make it difficult to produce homogeneous and relatively defect-free concrete. Reducing water content to extent, reducing water content to extend that suitability for construction work to be carried out is not compromised, makes it possible to use a lower cement content so as to achieve required concrete quality and to enhance cracking resistance. Says this says very differently. I understand what high water content not only makes uneconomical concrete that requires a high cement content to achieve same water cement ratio, but also makes concrete prone to segregation so as to make it difficult to produce homogeneous and relatively defect-free concrete, reducing water content to extent that suitability for construction work to be carried out is not compromised, makes it possible to use lower cement content so as to achieve required concrete quality and to enhance cracking resistance. An excessively low water content, however, makes the concrete very difficult to place, increasing possibility of initial defects such as incomplete filling in order to produce concrete that has required levels of strength, durability, water tightness, cracking resistance, and steel protection performance. It's very important to make water content as low as possible to extend that concrete is suitable for construction work to be carried out and is capable of filling form completely. Mixed design procedures. Mixed design procedures. In mixed design, characteristic values related to strength and durability of concrete described in design specifications as well as maximum sizes of coarse aggregate, slumps, water cement ratios, cement types and cement contents indicated as reference values are ascertained. What happens in mixed design? Characteristic values related to strength, durability of concrete as well as maximum size of coarse aggregate, slump, water cement ratios, cement types and cement contents. These are ascertained. Mixed proportions are determined on basis of reference values for concrete indicated in design specifications. Provisional mixes proportions. Provisional mix proportions to be used as reference mix proportions for trial are determined according to mix proportions as mentioned above. On basis of provisional mix proportions, thus determined trial mixes are prepared by using materials identical to materials to be used to ascertain that performance requirements for concrete can be met. If trial mixing has revealed that performance requirements cannot be met, materials or mixed proportions to be used are changed and mixed proportions need achieve required quality and are determined. Design specifications indicate characteristics values for concrete. Design specifications indicate characteristic value for concrete determined on basis of structural performance and durability of structure, such as specified strength of concrete, carbonation rate, chloride ion diffusion coefficients. What are these? These are performance and durability of structure. Structural performance and durability of structure. I read, design specifications indicate characteristic values for concrete determined on basis of structural performance and durability of structures, such as specified strength of concrete, carbonation rate and chloride ion diffusion coefficient. Design specifications also indicate maximum size of aggregate, coarse aggregate, slumps, water cement ratios, cement types and cement contents as references values to be used in cases where proven concrete mix proportions are used or mix design is. So I say here, design specifications also indicate maximum size of coarse aggregate, slump water cement ratio, cement types and cement contents as reference values to be used in cases where proven concrete mix proportions are used or mix design is conducted concretely. In mix design, therefore, it's necessary as first step to check on these characteristics values and reference values indicated in design drawings and specifications. Now, that figure shows concrete mix design procedure at construction stage. As shown in figure, mix requirements such as maximum size of coarse aggregate, slump, required strength, water cement ratio, and air content are determined on basis of reference values indicated in design specifications. As is shown in this figure, mix requirements as such as maximum size of coarse aggregate, slump, required strength, water cement ratio, and air content are determined on basis of reference values indicated in specifications. If reference values indicated in design specifications are thought to be inadequate in view of materials to be actually used or construction requirements, it's necessary to change those values into values suitable for actual condition. After ascertaining that characteristic values for concrete indicated design specs are met. Now you can just blow it down a little so you can see completely here. It's long one. It's a very long page. Issue we have to. It's a mixed design. It is mixed design. Mixed design this is an important one and can be read like that. You see, target performance of concrete. Target performance of concrete is a circuit here, and this you can say complete here. You can see this is target performance here. You can see this, and in this here sublines check items of design drawings and specification, and after checking them, characteristics values specified strength, carbonation rate, chloride ion diffusion coefficient, permeation rate, permeation coefficient, relative dynamic modulus of elasticity, shrinkage, strain, etc. It goes to reference values. So this is characteristic values, and those reference values a maximum size of coarse aggregate, slump water cement ratio, cement content, type of cement, air. It goes to define target performance, and then placeability you have to consider for that performance. You have to consider specified durability, so this is the number one circuit, this of that. Then we have to define mix requirements, and that is we have considered the reference values and then define target performance. That is based on placeability, specified distance, durability, and then we go to determine mix requirements. And here is maximum size of coarse aggregate, slump, required strength, water cement ratio, cement content, and type of cement, air content. And we go further down. That's step 3, selecting materials and determine provisional mix proportions. It's say here, and again another circuit is that's trial mix. It was Target performance of concrete is target and its proposal. In fact, this is proposal. Select materials and determine provisional mix proportions. Then we have trial mix. You can conduct here trial mix for this pose, and trial mix, step. There's unique quantities of materials. Adjust water content. Water content will 175 kg per meter cube or less. Adjust cement content. Control of heat of hydration. Confirmation of cement content. Adjust sand percentage. Adjust add mixture content. This is here. It goes to fresh concrete quality acceptable, if not acceptable. And the question is first quality, fresh quality is acceptable, or hardened concrete quality acceptable. And this is no air, go back to this. And then say step 5 is determine mix proportion, determine ingredient content. So here are stages. You can say first one is mix design. In this is this check item obligation drawings, which is what is defined type performance. Then this determine mix requirements. Okay, and there's you can say here is we can say step 4 adjust quantities materials, and then fresh quantity acceptable, not acceptable, and then determine mix proportions, determine ingredients control. So this is a really interesting one. We have to discuss it thoroughly, and then we can say appropriate mix proportions difficult to select, and that's one point you can say here. It is according to determined mix requirements, provisional mix proportions for concrete consisting of materials to be actually used are determined. After that, trial mixes are prepared to make sure mix proportions thus determine meets performance requirements. If performance requirements are not met, mix proportions is modified and trial mixing is carried out. If performance requirements cannot be met by mixing proportional modification alone, methods we use are changed, and this process is repeated until performance requirements are met. If trial mixing has revealed that water content needed to achieve required consistency would increase considerably, it is important to reconsider and modify physical properties of aggregate by, for example, using other types of aggregate, increasing solid content, or adjusting particle size distribution if water content of concrete containing an air and draining water reducing agent exceeds upper limit 175 kg of concrete per cubic meter, that is water reducing agent, not to allow, and without that water, but upper limit of change using water content should be reduced by using super plasticizer as a means of enhancing cracking resistance. Measures such as changing type of cement used to a low heat type or using expensive admixtures should be taken. We have here a very important part of this specification, and that's trial mixing. After that we continue this That is performance of concrete. We'll see. It's very important. Performance, so many, so all this we have to see later on. And workability of concrete, so it's this much we have to see. We are going here for this, that is, it's very important one. Really professional work here. We have to take care of this. As I say, Suraj underscore engineer, SURAJ Suraj underscore engineer at yahoo.co.uk. This is professional engineering certificate. And this is quality talk, and here is coordination engineering, here is concrete classroom. I think today's taken this quite seriously. I try to take this fact same seriously, to understand all this very seriously, and comfortably as well, because it's concrete, very long term material. We cannot avoid this at any cost. It's really important point to understand. You can meanwhile read this for 5 minutes. I'll be back, just because you can read this for understanding. It's better. Step 2, first you take step 1 and read it, and then you'll say step 2 in this case, please. So I hope you have taken it seriously and you have known this. I understand that we have gone through a good talk in this case today. Of course, it's not very long, just 3 hours. It's okay, means from this point of view, I don't mind that. It's okay, and I like to tell you that we'll continue this talk of concrete whenever I mean next time, because it's very important one and no one can deny this fact. It's very important one, and we have to be really very careful from this point of view what we are saying, and it's really interesting to hold it like that. And with this I thank you very much. I'll take your leave today.